Okay, so from here you can see that so you need to find the F31 and F32. Okay, so you repeat again this question. Okay, basically for this type of question you need to add up the forces according to the components. Okay, so you have the X component and the Y component. Okay, so X component and Y component. Right, so for this question, you need to find two type of forces. Okay, the first one is F32. Okay, so F32, obviously F32 is the positive charge. Sorry, F32 from the positive charge Q3 and Q2. So the force will be going upward. Okay, going upward. So for X component is 0, so there is no force on the X component. But for the Y component, because this one is going upward, so the Y component is positive, so positive Y. So it will be positive F32. Okay, so for F31, for the X component, okay, for the X component, you can see that the theta here is 30 degree. So here for this F31X, okay, you will use the cos, so it will give you F31 cos 30, while the F3Y, you can see that the force is going down, okay, and going down here, so we will use F31 sine 30. Okay, so the concept is very easy. Okay, for F31, let's say F31 is like this, F31. For F31, so you need to resolve it to two component, X component and Y component, F31X and then F31Y. You can see that for F31X is going to the right and F31Y going to the going downward. Okay, because from the tail to the head, you need to ensure that the direction is in one direction only. So going to the right, going down. So one direction from the tail to the head. So for F31 is positive. Okay, for F31X is positive. For F31Y is negative. Okay, so next from there you can obtain the F net, the sum of F. Okay, the sum of F here. So you can add up the here. Okay, to find the F31 and F32, you can use the formula F equals to KQQ over R squared. So please ensure that Q here need to be in modulus. For example, you want to find the F32. Okay, F32 equals to KQ3 Q2, okay, over R squared. Okay, so K is 9 times 10 to the power of 9. Q3 is 65. So 65 times 10 to the power of negative 9, because in micro, CCT millimicro. Sorry, 10 to the power of negative 6. Okay, micro is negative 6. Okay, 65 times 10 to the power of negative 6 times with the Q2. You can see that Q2 is positive 50 micro. So 50 times 10 to the power of negative 6. Okay, over the R square. R is the distance between these two charges, 32 and 33, Q3 and Q2. Distance is 30 cm, so convert to meter will give you 0.33 square. Okay, so you will obtain the the Newton here. So put this value here. Okay, F32, put this value here. F32, positive F32. Okay, right. And for this one, F31 cos 30 and F31 sin 30, you can try it at home. Okay, and for F31, you can see that the distance is 60 cm. So the 60 cm, the 60 cm is 0.6 meter. So please convert the R there to be 0.6 meter. So R is R squared, so 0.6 squared. Okay, right. So try this question. Okay, because I think there is an answer after this slide. Okay, so the answer is 290 at an angle of 65. Oh, angle. If you want to find the angle, okay, so theta is tangent negative 1 f f fy over fx. Okay, fy over fx. So this value fy over fx, tangent negative 1, you will obtain the theta. Theta is the angle between the poles. Right? Okay, we will move on to the electric field. So electric field is exists around the charged object. Okay, so it's a vector quantity. Okay, for example, if for the positive charge, you can see the electric field is going out like this. For the negative charge, the electric field is going in. So this is the electric field. Okay, and the formula, there are two formulas. The first one is E equals to F over Q, and another one is E equals to KQ over R squared. Okay, E equals to KQ over R squared. Right? So this is the properties of the field lines. Okay, the field is tangent to the line. The magnitude of the field is proportional to the density of the lines, and the field lines will start on positive charge and end on negative charge. Okay. So if the question asks you to draw, so to draw the field lines, so this is what you will draw. Okay, when for the positive charge, the field is going out, and for the negative, it's going in. Okay, so if you have two charges like this, so you will obtain a pattern like this. Okay, so field line patterns for object with unequal amount of charge. You can see that for these two charges, this positive charge here stronger than this one. How we know? By looking at the field lines, where we can see that the field line for this charge is more than compared to this one. Okay, so this charge is stronger than this one. Okay, right. Same with this one, positive and negative here. So this positive charge is stronger than negative charge because the field line is more here, right? So in our daily life, some examples of electric field happen in our daily life, such as lightning, okay, Patrick trick, magic balloons, okay, small spark in blanket at night, pieces of paper attracted by comb. Okay, so this is 4 examples, right? So the example here, calculate the magnitude and direction of the electric field at point P, which is 30 cm, okay, 0.3 meter to the right of a point charge Q. So we have a charge Q. Okay, this is Q, which is a negative charge, negative 3 times 10 to the power of negative 6. And the question asks you to find the electric field, the E, electric field, at point P, which is to the right. So to the right here, so P here. Okay, let's say P is here. So, okay, P is here. So the question asks you to find what is the electric field here. So you know that the distance here from this point to the charge is 0.3 meter. Okay, so E, you know that E will give you E equals to KQ over r squared. So q, you need to modulus the q. Okay, so E equals to k. K is 9 times 10 to the power of 9 times 10 to the power of negative 9. Okay, times the q. Q is negative 3 times 10 to the power of negative 6, because we know modulus. So it will give you 3 times 10 to the power of negative 6. Okay, sorry. Okay, so for okay, k is 9 times 10 to the power of 9. Okay, sorry, 9 times 10 to the power of 9. Q is 3 times 10 to the power of negative 6. We have a modulus the q, so 3 times 10 to the power of negative 6, okay, over r square. R is 0.3 squared, right? So you will obtain the value, okay, Newton per coulomb, the electric field value 3 times 10 to the power of 5, and the direction is to the left. Okay, to the left. Why to the left? Because this is the negative charge. Because we know that for negative charge, let's say the point is here, P here. So for negative charge, we know that the field line is going inward, or towards the charge. So for this part, to the left, right? So for this question, the electric field that we obtain here, the direction is to the left, right? Okay, so you can try this question at home. Okay, find the electric field at point A and find the electric field at point B. Okay, this concept of calculation is same with the electric force, but the one that different is the formula. For the electric force, we can see that the formula AF equals to KQQ over R squared, and Q here we need to modulus. But for the electric field, we can see that formula is E equals to KQ over R squared. There is only one Q. Okay, so please try this question. Okay, you can ask the lecturer if you don't obtain the answer, right? So this is the answer for A and B, right? Okay, next is electric flux, right? So for electric flux is the how much E electric field penetrate through the surface. Okay, so let's say we have the electric field, a lot of electric field. Okay, we can see the electric field, and then let's say we have a surface here. Let's say we have a hole here. Okay, a square hole. Okay, so those electric field that penetrate through this hole or this surface is being called as electric flux, where we will use this symbol, electric flux. So electric flux is how much E that penetrate through surface. Okay, and the formula is EA or EA cos theta. E is electric field, A is the surface area. Okay, surface area means that in meter squared. Okay, and or we can use EA cos theta. Okay, so there are two situations: either the flux is maximum, okay, when theta is 0, or the flux is 0 when theta is 90 degree. Okay, when the surface is the theta is 0, like this example, the flux is at maximum. Let's say you have an electric field like this. Okay, electric field like this, but the surface is like this. Okay, the surface is, let's say we have like this. The surface is 90 degree like this, because this is normal line. Okay, so you can see that the angle between the E and the surface is 90 degree. So when this happens, you can see that there will be no electric field that will penetrate to the surface. Okay, so at this as example, you can see that this flux will be zero. The electric flux will be 0. Okay, right, when theta is 90 degree, right? So for this question, the flux, electric flux, equals to EA. E dot A. A is the surface area and E is the electric field. Okay, or EA cos theta. EA cos theta. So in this question, theta is 30 degree. Okay, you can try this question. And Gauss law. Okay, then we move on to the Gauss law. Gauss law is the total flux within a closed surface, and it's proportional to the enclosed charge. Okay. Gauss law is always true, but it's only useful for certain very simple problem with great symmetry. Okay, for the Gauss law, you can see that is the total flux within a closed surface. You can see that this is the integration, the closed integration, E dot dA. So we have a closed surface, okay, like this. So Gauss law can help you to find what is the total charge for this surface, okay, closed surface. And the formula is, okay, you can find that the equation is E dot dA, while for the spherical Gaussian surface, when you integrate the dA, we will find the pi r squared. But for pi r squared, this is the surface area of a sphere. So from here, the E for pi r squared, okay, is the surface area of a sphere, okay, equals to Q enclosed. Q in means that Q inside the spherical inside the sphere, okay, and over epsilon naught. Epsilon naught is the constant for epsilon naught is the constant for okay, epsilon naught is the constant 8 times 8.85 times 10 to the power of negative 12. Okay, and when you derive this one and you move on this bracket parameter here to this side, you will obtain that like this. So you obtain the equation E equals to KQ over R squared, where this is where we use in the Coulomb's law. Okay, KQ over R squared, KQ over R squared. Okay, and very brief introduction to the graph. For the conducting sphere, you will obtain a graph like this, E times E versus R, where we will see that the graph will be exponential or inversely proportional, inversely exponential like this. Okay, while the decay is 1 over R squared. But for the non-conducting sphere, we will obtain a straight line like this to the R, to the radius, and it will decline like this in exponential. Okay, 1 over R squared. So this is the difference, where we can see that for the conducting sphere, okay, for the conducting sphere, the graph will start from the line will start from the R here, and for the non-conducting sphere, the line will start from the 0. Okay, so inside means that inside the we will obtain a straight line here, the proportional line here from inside the sphere. Okay. Okay, thank you for your attention. Assalamualaikum.